I have a different backdrop for this video because you guessed it, I'm doing this video from my dining room. I like to keep you guys on your toes, so I don't like to do the videos in the same spot every single time. So this time I'm in my dining room doing the video forecast, and we're going to start by looking at the radar here. And as you can see, Winter Storm Fern is taking shape across the south central U.S. Precipitation is beginning to overspread the region, and there are already numerous reports of snow, freezing rain, and plain rain across both Texas and Oklahoma. Road conditions will only continue to deteriorate throughout the overnight hours as snow, freezing rain, and even sleet continue to increase in intensity and in coverage across the area. So if you live in this area and you don't have to go out tonight, stay home. Don't go out in this. I mean, especially if you live in an area that's going to get freezing rain, travel is going to become life-threatening, if not altogether impossible. But then also in the snow region where you're going to get up to a foot of snow or more, especially in Oklahoma and portions of northern Texas, travel conditions are going to be just as bad. So if you don't have to go out, stay home. And now I want to take a look at the models here. So let's move to the models. All right, I want you to focus your attention here in the south central U.S. across Texas and Oklahoma. And I'm going to move this along here and look at this. You get two waves of precipitation. There's the first one and there's the second one. And I'll show you what is occurring in the upper levels because that can explain why you're going to get two distinct waves of precipitation across Texas, Oklahoma, and that region in the south central here. So let me move to the upper levels. And listen, guys, I don't pretend to know everything, but I do know some stuff about weather. So let me show you here. This is the reason. So you see this energy sneaking out of, this is going to be the main piece. That's going to be this, that's going to bring the main storm. But you get this sneaky energy here. Let me move this along. Look at that sneaky energy getting out ahead of this main piece right here. That's the main piece. That's going to bring the big daddy. And look at this. This is the northern piece. That's going to dig southward, and that's going to steer this storm to the north and east. And look at that. You have that southwest flow coming around the base of the trough, and that's where the surface storm is going to head to the north and east. But then you also have, and I want to show you because this is an interesting setup, this is a southern branch storm. So you're going to have the southern branch jet stream and the northern branch jet stream coming together. So you're going to have this confluent zone here helping to enhance precipitation across the region. And then with that southwest flow, you're going to drive all that precipitation northward, and you're going to get a large precipitation shield. And I want to show you that on the surface map in just a second, but you're going to get a really large precipitation shield. And that's due to, there's a lot of reasons really, but I'll boil it down to just a few. You get that confluent zone that helps to enhance precipitation, and that will drive it northward. But then you also have, because you have the Arctic air mass in place and you have that low pressure forming, you're going to have a lot of warm air overrunning cold air, and you have ample moisture, you're going to get a huge precipitation shield. And let me show you what it looks like at the surface. You can see just what I mean by it being a very large precipitation shield. All right, let's see here. It's loading in. All right. So like I said, this storm is going to be very, very large. And I mean, it's going to be snowing in Texas and Oklahoma at the same exact time that it is snowing in Pennsylvania and New Jersey. Look at that. That's how big this storm is. And that's why I would show you right now, but I want to just look at the models for this video. But you have winter storm warnings all the way from the Texas and Mexico border all the way up into the state of Maine. That's greater than 2,000 miles distance-wise. So that's why this storm is massive, and that's why you have such a large warned area from the National Weather Service because of just how massive this storm system is. Now I want to show you, I'm going to move this along here. And so you're going to get this heavy snow on the northern end, and you're going to get in here where you get warm air aloft and cold air at the surface because you're going to have that cold Arctic air mass at the surface, but you're going to get warm air aloft. So it's going to melt the snowflakes, and it's going to result in freezing rain. And you're going to get in this area here, and that's why there's some ice storm warnings across this region and across this region. That's because you're going to get 1 to 2 inches of ice accretion, which is going to, like I said earlier, it's going to result in down trees, down power lines, extended power outages. And in this Arctic cold, that is no good. And that's a very dangerous situation. If you don't have to travel, do not go out and travel because road conditions are going to be awful. They're going to be life-threatening, completely treacherous. Don't go out. If you don't have to go out, don't go out. There should be no reason that you have to go out. I know some people are essential workers, but other than that, if you don't have to go out, just stay home and enjoy a day at home. But now I want to show you something else. So this is where I want to show you where I'm most uncertain about snowfall amounts. And that's going to be in southeastern PA. Because look at this. I want to show you here. So right now it's all snow, but you get this warm air aloft moving northward, and that's because of the southwest flow aloft. Let me show you the upper levels and what I mean by that. But you're going to get warm air flowing in aloft. Look, so you have the flow out of the southwest. The wind is coming, follow my cursor. That's where the wind is coming from. So you're getting flow out of the south. So it's going to result in warm air advection aloft. So the mix line is going to push northward. How far north does that mix line push? How long can the cold Arctic air hold on before the warm air starts to erode the cold air and start resulting in sleet or freezing rain in some areas? In Pennsylvania, I think if it does change over, it's going to change over to sleet. I don't think you're going to get freezing rain out of it, but it's going to, I don't know how far north that line gets. I think it stays south and east of Harrisburg. The furthest north I believe it could get is Harrisburg at this point in Pennsylvania. But then look at this. You start as a nice period of snow in New Jersey, and then it does eventually change over. Northern New Jersey, you stand the best chance of staying all snow, but you get snow, a decent period of snow also in New York City, but then it does end up changing over. And let's zoom. I want to zoom in on this real quick. Let me zoom in. Look at New York City. New York City, you are right on the line. I mean, you're going to get a nice period of heavy snow. Look at this, a few hour period of heavy snow, but then by evening time, the mix line does push into the city, but you are right on the line of the rain. It could change over to plain rain towards the end of this storm system, but you're still going to get a decent amount of snow out of this. And I think you're going to get close to a foot of snow still. And let me show you what I'm looking at here. I'm going to show you the snowfall output. And we're just looking at the European right now. I can do another video later going over the UK Met and like what they're showing. But look at this. And the reason I say, so it's showing 7 inches here. The reason I say you can get 8 to 12 inches out of this is because this is factoring a 10-to-1 snow ratio. But when the snow starts, I'm going all over the place. I know, I understand. Let me move back to the precipitation. I want to show you. Okay, so here's the precipitation coming in. Let's go to the temperatures, the surface temperatures. Look how cold it is in New York City. 11 degrees Fahrenheit up to 15 by 1 p.m., 16, and then 20. Now you're going to get warm air aloft, and that's why it's going to change over. But when it's snowing, you're going to have high ratio snows, so you're going to get more than a 10-to-1 snow ratio. I could see a 12 to 14 snow ratio as opposed to a 10-to-1 ratio, especially in the onset of this storm with how cold the temperatures in the atmosphere is going to be ahead of the storm before the warm air aloft starts kicking in and taking effect. So I do believe 8 to 12 inches is on the table for New York City. And then Boston, I think you're in the 12 to 18 here. Let me show you here. I'm going to zoom. I'm going to stay in here. Look at this. Boston, looks like you stay all snow. Boston stays all snow, but you're kind of close to that line, but you're not close enough where I think 12 to 18 is good for Boston. And Cape Cod, look at this. You start to change over around 10 p.m. tomorrow evening, and then you do go over to, it looks like plain rain. Now, before we end the video here, I know this is going to be a longer video, and that's fine. We're diagnosing this storm, so it has to be a long video. Let's look at the UK Met. See, the UK Met keeps you pretty much all snow in Cape Cod. I mean, you change over, but it doesn't take that line as far north. I mean, look at New York City, for example. You pretty much stay all snow except for like the very, very end where you might switch over to some sleet. So it really, I mean, there's agreement in terms of track, but how long does that cold air hold on for? And how much warm air advection aloft is there? Let me show you. I'm going to zoom over to Pennsylvania. So here's the UK Met, and this is over Pennsylvania here, okay? So UK Met, and look at the European. And this is the most recent European run. See, look, it has the mix line approaching Harrisburg. all over southeast PA, you're getting sleet and or freezing rain, especially closer to Philadelphia. But now look at the UK Met again. UK Met. Let's look at the UK Met one more time. Look at that. Yeah, you get some mix coming up into far southeastern PA, but it keeps most of its snow. And then it changes over by 10 p.m. before the storm exits and pushes off to the northeast. So that's the question. How far north does that rain to snow line get? I think right now, especially across PA, I think that southeast of Harrisburg and points to the south and east, I think it does change over, starts to change over from south to east around 3, 4 p.m. And then by 10 p.m., 7 p.m. to 10 p.m., I think most of the southeast Pennsylvania is over to sleet and or freezing rain. But there's not a whole lot of agreement because look at the GFS. I'm going to show you what the GFS is showing real quick before we go. Here we go. Look at this. All right. This is 7 a.m., 10 a.m., 1 p.m., 4 p.m., 7 p.m., and 10 p.m. And look at that. See, there's not a whole lot of agreement, but I think that the best chance, I think 8 to 12 works out best for south and east of Harrisburg, and then 12 to 18 through most of the state, and then 8 to 12 up in the northwest quadrant for PA. So stay tuned. If anything changes, I'll let you guys know. Sorry for the long video, but I figure there's a lot to go through, and it's just too much to talk about. I could go on for hours about this stuff. Thank you guys for watching. Hope you guys enjoyed, and make sure to drop a like and subscribe.